is all rain you see falling down right now. It is not snow. The flooding concerns involve the American Canyon, the Truckee River. Whole house.
Widespread rain is returning to Northern California, and after the storm we just got, it could spell trouble for the Sierra and the foothills. Live Copter 3 was over the Sierra today. There's still a lot of snow on the ground, covering homes there. With tonight's warmer system on the way, that snow could melt in many of those areas.
Authorities say 8 skiers have died after they got trapped in an avalanche near Lake Tahoe. Emergency crews reached their bodies earlier today. One of the skiers, another skier, is still considered missing.
The number is 6,229 feet. That is not a forecast. That is not a projection. That is the current elevation of Lake Tahoe, right now, sitting at its absolute legal maximum capacity. Every drop of water that the law permits is already in that lake. And somewhere deep beneath that gorgeous, glittering surface, something the Earth has been building toward for 4,000 years is beginning to stir. Most people look at Lake Tahoe and see paradise. The crystalline water, the mountain skyline, the postcard-perfect beauty that makes it one of the most visited destinations in America. But right now, there is a conversation happening between geologists and seismologists that almost nobody on that shoreline knows about. And when you hear what they are watching, you will never look at that lake the same way again. Stay with me. Because what is unfolding beneath that water right now is the most consequential geological story in California, and almost no one is talking about it.
Dangerous conditions has forced the Palisades Tahoe Resort to shut down for the day.
From dying lake to dangerous lake, how did we get here? 5 years ago, Lake Tahoe was in crisis. The California megadrought had stripped the lake down to levels not seen in living memory. Ancient tree stumps that had been underwater for decades broke the surface like they were rising from the dead. Boat ramps ended in dry air, stranded dozens of feet from the water's edge. Marina owners watched their revenues evaporate. Residents quietly asked whether they were watching a permanent transformation, not a dry spell, but a dry future. Climate scientists were sounding alarms. Some warned that the Sierra Nevada snowpack, the frozen savings account that feeds Lake Tahoe every spring, might never fully recover. And then, the atmosphere did something extraordinary. Beginning in late 2022, a series of massive storm systems hammered the Sierra Nevada one after another. These were not ordinary storms. Meteorologists tracking the snowpack watched in disbelief as numbers climbed past historic benchmarks. By the peak of the season, Sierra snowpack had reached 237% of normal, nearly 2.5 times what that mountain range typically holds. Think about that. 2.5 times. The mountains had essentially become a colossal frozen reservoir, storing billions of gallons of water above the Tahoe Basin, quietly waiting for spring. And when spring came, that reservoir unlocked all at once. Water surged down creeks and tributaries faster than hydrologists had projected, faster than water managers had prepared for. The lake rose 4 feet in a single season. Officials scrambled to open dam gates at the Truckee River outlet at maximum legal flow rates. Engineers monitored inflow and outflow numbers around the clock, and still the lake kept climbing. By early 2024, Lake Tahoe had reached its legally defined maximum. Beaches that had been cracked and dusty 2 years earlier were once again submerged. Kayakers returned. Swimmers filled the shallows. Tourism officials celebrated. The headlines called it a miracle. California's water crisis finally over. But here is the question nobody in those headlines was asking. What happens when billions of tons of water return to a basin sitting above one of the most dangerous fault lines in America?
Protecting Lake Tahoe while balancing sustainability and conservation. That's the theme of this year's Tahoe Summit.
And listen to this, bipartisan leaders from California and Nevada came together to try and reach that goal.
The fault. Nobody warned you about. Let's talk about what is actually underneath Lake Tahoe. not the water, not the sediment, the geology. Because running directly beneath that lake bed for approximately 25 miles is a fracture in the Earth's crust known as the West Tahoe Fault. Scientists have studied it for decades. Researchers from the University of Nevada, Reno, and the United States Geological Survey have mapped it, measured it, and analyzed it in detail. What they found is deeply unsettling. The West Tahoe Fault is capable of generating earthquakes as powerful as magnitude 7.3. For context, the 1989 Loma Prieta earthquake, the one that collapsed freeway overpasses across the San Francisco Bay Area and killed 63 people, measured 6.9. A magnitude 7.3 earthquake releases roughly 2.5 times more energy. And the scale is not linear. Each decimal point on the Richter scale represents a dramatic leap in destructive force. A 7.3 would not simply be slightly worse than 1989. It would be categorically, overwhelmingly more violent. But the magnitude is not what troubles geologists most. It is the timeline.
With breaking news in the Lake Tahoe area, a series of earthquakes that caught a lot of people's attention tonight. The largest of the quakes, a 4.7 magnitude. This happened around 9:30 this evening.
Scientists have pulled sediment cores from the floor of Lake Tahoe. They found evidence of ancient ruptures, underwater fault scarps, which are essentially steep steps in the lake bed formed by prehistoric earthquakes. By analyzing layers of displaced sediment preserved in those cores, researchers were able to determine when the last major rupture occurred, 4,000 years ago. Based on the measured rate at which stress accumulates along this fault and the geological patterns of its behavior, researchers believe the West Tahoe Fault may be approaching, or may have already passed, the end of its seismic cycle. In straightforward terms, pressure has been building in that rock for 4,000 years without a major release. So let me ask you directly, if you knew a structure had been under maximum stress for 4 millennia, and someone then added billions of tons of additional weight directly on top of it, what would you expect to happen?
You are looking at the bottom of Lake Tahoe, nearly 1,500 feet below the surface. And those little particles you see floating around there are rich with nutrients.
Water triggers earthquakes, and the science proves it. Here is where this story moves from alarming to documented. Large bodies of water can trigger earthquakes. This is not a fringe theory. It is peer-reviewed, historically verified scientific fact. In 1967, India's Koyna Dam reservoir triggered a magnitude 6.3 earthquake that killed 180 people. Lake Mead behind Hoover Dam has generated hundreds of small earthquakes since it filled in the 1930s. China's Zipingpu Reservoir may have contributed to the catastrophic 2008 Sichuan earthquake that killed nearly 70,000 people. Scientists still debate the precise causal link in that final case, but the broader pattern across the historical record is not seriously disputed. The mechanism works through 2 pathways. The first is straightforward: sheer vertical weight. Billions of tons of water pressing down on the crust adds stress to fault systems already under horizontal tectonic pressure. The second pathway is more insidious and more dangerous. Water seeps into rock fractures and increases what geologists call pore pressure. That elevated pressure reduces the friction that keeps fault surfaces locked together. In effect, water lubricates the fault plane, making it dramatically easier for 4,000 years of accumulated strain to release, suddenly, violently, and without warning. Now apply that directly to what is happening at Lake Tahoe right now. Maximum capacity, maximum weight, maximum pore pressure. All of it bearing down simultaneously on a fault that was already considered critically overdue. And the seismographs are already responding.
Well, Lisa, it is just a gorgeous day here in South Lake Tahoe. Clear skies, clear roads, and you know what? The snow is already melting. Businesses and homes are seeing the melting snow.
The instruments are detecting something, and scientists are watching 24/7. Inside the monitoring stations positioned around the Tahoe Basin, seismographs trace their continuous lines across digital screens. Every tremor registers. Every subtle shift in the Earth's crust leaves its signature. And lately, those signatures are changing. Recent monitoring data from stations around the basin reveals an increase in small earthquakes along the West Tahoe fault system. Magnitude 1.9 tremors have been detected in recent months. To be clear, you cannot feel a magnitude 1.9 earthquake. You could be standing directly above one and never know it happened. But the instruments feel everything, and they are not staying quiet. Seismologists call this microseismic activity. And while a 1.9 sounds harmless, earthquake scientists recognize these small tremors for what they can represent: potential precursors. Warning signals from a fault system under increasing stress, the geological equivalent of a building groaning before a structural failure. The 2011 Tohoku earthquake that devastated Japan and triggered one of the deadliest tsunamis in recorded history was preceded by an increase in smaller quakes along the same system. That pattern has appeared before major ruptures across the world, repeatedly. Here is the honest scientific position. Nobody can tell you these tremors are definitely building toward a major rupture. They might slowly release enough strain to delay one. They might mean nothing at all. But what scientists will say, unanimously, is that the combination of factors currently present at Lake Tahoe is not something anyone is willing to dismiss. The water is at maximum, the fault is overdue, the tremors are increasing, and the clock is ticking.
Even though the Tahoe Summit celebrates bipartisanship, California leaders do tell me that they are concerned about the decisions made on a federal level to cuts made to the Lake Tahoe area.
If the fault ruptures, the earthquake is just the beginning. Here is what most people do not know about Lake Tahoe's underwater. Geography. The lake does not gently slope down to a flat bottom. It plunges. In some areas, the walls drop nearly vertically to depths exceeding 1,600 feet. Massive formations of loose sediment cling to those steep underwater gradients, held in place by nothing more than friction and geological patience. A magnitude 7.3 earthquake would shake those formations with sudden, catastrophic force. The sediment would not hold. Scientists believe the result would be massive underwater landslides, millions of tons of material collapsing into the lake's depths simultaneously, in seconds. And when that much displaced mass hits that much water that fast, it generates a tsunami. This is not theoretical modeling built on assumptions. Geological evidence confirms it has already happened. Researchers examining the lake bed identified the preserved remnants of a prehistoric catastrophe known as the McKinney Bay landslide, which moved approximately 12 cubic miles of material in a single ancient event. Modern computational models project what a comparable event would produce today. Waves potentially reaching 30 feet or higher, traveling across the lake at speeds approaching 100 miles per hour. And here is what makes Lake Tahoe uniquely, terrifyingly dangerous compared to ocean tsunamis. The lake is only 12 miles wide at its broadest point. Ocean tsunamis give coastal populations hours to evacuate. Warning systems detect the originating earthquake far offshore and issue alerts long before the waves arrive. Lake Tahoe offers no such window. The earthquake and the first wave would arrive within the same terrible minutes. Residents would feel the ground shaking and watch the water rising simultaneously. And then, because the lake is an enclosed basin, the waves would reflect off surrounding shorelines, bouncing back and forth, striking communities multiple times. The first wave would not be the last assault.
And you know what? Some shaking up there in Tahoe today, rattled by a quake this morning. And it was felt all the way down here in the valley and in Sacramento. A magnitude 4.2 quake hit right in the middle of the lake.
55,000 residents. No warning system, no evacuation plan. Approximately 55,000 people live in the Lake Tahoe basin year-round. But that number is only the starting point. Summer weekends push over 100,000 visitors onto those shorelines. Ski season fills Nevada casinos and California resorts with thousands more. On any given holiday weekend, the population surrounding that lake can effectively triple, all of them compressed into a mountain basin accessible by a handful of narrow two-lane highways that already jam under normal summer traffic. During a mass evacuation with minutes on the clock, those roads would become parking lots. The jurisdictional reality makes the problem worse. Lake Tahoe straddles the California-Nevada border. 5 counties share responsibility for shoreline communities. 2 state governments, multiple fire districts, and dozens of local agencies. would need to coordinate instantly during a crisis that unfolds faster than most emergency management systems are designed to respond to. And the warning infrastructure simply does not exist. Ocean-facing communities have tsunami sirens. They have clearly marked evacuation routes. They have decades of public education campaigns explaining exactly what to do and where to go when the ground shakes. Lake Tahoe has none of that. No sirens line the shoreline. No tsunami evacuation zones have been established. No public awareness campaigns explain what lies beneath the surface of the water that families are swimming in right now. Property values along that shoreline exceed $15 billion, built on the quiet assumption that the lake is safe. So here is the question I want you to sit with. How do we protect communities from a threat most of them have never been told exists?
Scientists say that a snow drought likely contributed to that deadly avalanche and say the risk is still high for another one to hit the Sierra.
What science can and cannot tell us. The monitoring technology surrounding Lake Tahoe has never been more sophisticated. Modern seismic networks detect earthquakes too small for any human to perceive. GPS stations measure ground deformation to millimeter precision. Satellite imagery tracks surface changes invisible to the naked eye. Researchers from the University of Nevada and the USGS analyze every tremor, mapping locations, measuring depths, tracking frequency week by week. And yet one fundamental limitation remains completely unchanged. Earthquakes cannot be predicted. Scientists can identify faults. They can calculate probability windows. They can recognize warning signs and measure accumulating strain. What they cannot do, what no instrument, model, or algorithm has ever successfully done, is tell you when. The Earth does not issue announcements. A fault can remain locked for centuries past its average rupture interval, or it can fail tomorrow morning. The uncertainty is absolute, it is unavoidable, and it applies fully to the West Tahoe fault right now. But here is what scientists will say, and what they say unanimously. The fault will rupture, not might, will. Faults that accumulate strain must eventually release it. That is not opinion, that is physics. The West Tahoe fault has been building pressure for 4,000 years. That pressure will find release. The only remaining questions are when and how violently. Until then, the researchers watch their instruments. Graduate students spend years studying sediment cores pulled from the lake floor, analyzing the preserved evidence of prehistoric catastrophes to understand the rhythm of a fault that operates on timescales that dwarf human civilization. Funding for this work remains limited. The West Tahoe fault generates no dramatic headlines, no ruptures in living memory to keep it in public consciousness. Research dollars flow to the San Andreas and other famous systems, while Tahoe's hidden threat receives a fraction of the attention scientists believe it deserves. The lake looks exactly the way it always has. Right now, somewhere on the shores of Lake Tahoe, a family is spreading towels on the sand. Children are running into the water. Boats are cutting slow lines across the surface. Someone is photographing the sunset and deciding that this might be the most beautiful place they have ever seen. They will post the image. They will tell their friends. They will not see what lies below. Beneath that postcard surface, 4,000 years of accumulated strain sits locked inside fractured bedrock. The West Tahoe fault does not care about tourism revenue. It does not care about property values or holiday weekends or the 55,000 people who have built their lives along its shores. It operates on geological time, patient beyond anything the human mind can genuinely grasp, slow beyond measure, but not stopped, never stopped. The lake has reached 6,229 feet, maximum capacity. Billions of tons pressing down on ancient fractures with relentless, unceasing force. The atmospheric rivers delivered what California desperately needed, and the headlines celebrated the miracle. But the water that refilled this lake did not simply restore what was lost. It added a critical new variable to a geological equation that was already dangerously unbalanced. The tremors continue registering on instruments most nearby residents will never see. The scientists continue watching data most nearby residents will never read. The emergency infrastructure gaps remain unfilled. The warning systems remain unbuilt. The fault remains unmoved, still accumulating, still waiting, still pressing toward a conclusion that no one can schedule and no one can stop. And so the question that every seismologist studying this region carries with them quietly grows harder to ignore with each passing day. Has the fault beneath America's most beautiful lake finally reached its limit too? If this story concerns you, it should. Share this video. The communities living on that shoreline deserve to know what is building beneath them. And if you want to go deeper on induced seismicity, fault mechanics, or what preparedness at Lake Tahoe should actually look like, drop it in the comments. We will cover it.